Guys, so you'll see that when it comes to if statements and so forth, that there are these problems here. There are these problems here that's recommended that you should just get intuitive about if statements. So question 1, question 2, question 3. I have a little problem that we will look at now as well, but remember there are these. So when I'm in pastoral assignments, remember I'm talking about these. So there's arrays, while loops, if statements, plus branching. So for homework, I highly recommend, so if you look here, I highly recommend that you try tutorial. So this is tutorial 4, question 1 and question 2. So go and look at try this question on your own over here. Because remember, the only way you really learn an MPR is if you can do questions like this. So piecewise linear function is given as this. And then we have another one. A smooth Heaviside function is given by this, blah, blah, blah. So look at this question. See, these are just if statement questions. See if you can do these on your own. Okay. But the question I want to look at is this specific question. This is a very, very nice question, and it really explains the idea of if statements and everything quite well. Okay. So it's actually kind of an introduction into nested structures as well, if statements and nested structures. So let's open our code here. So basically what you're looking at now is we're actually now getting more into nested structures. We're getting into nested structures. And a nested structure really is, it's just, there isn't really an exact definition of it, but it's just combining different logic in such a way that so that's actually just nested structure basics. So nested structure is just combining, so it's while loops, so it's combining while loops, uh, for loops, so for loops and if statements. These are like the if statements. So these are the while loops, for loops, if statements, and even arrays to create a new function, like to perform a complicated action. So it's just combining these things in such a way to do something really. Like it depends on what you want to do. Because remember, each while loop has a set of rules, for loops has a set of rules, if statements and arrays. Each of them are kind of different. So if you combine them in such a way, it's like a puzzle really. And you combine them in such a way, the logic it will do something, and there will be some sort of output based on what you want. Okay. So let's get into a quick question. Okay. So we're gonna get into a quick question. So I come here and let's look at this one. So they say consider the simulation of the diffusion of a particle in a medium. The particle starts in the center of a cell 11 by 11 by 11 grid at time step 0. Every second the gas molecule has an equal probability to move up 1 square, move down by 1 square. So we've got probability, we've got a little gas molecule starting in the center of a grid, and it has probability to move up 1 square, move down 1 square, move 1 square to the left, 1 square to the right, or stay in the same cell. So they say write a Python program that will simulate the movement of the particle until it is outside the original 11 by 11 grid. Use the name xlog for the x location of the particle, and use the name ylog for the reference of the y location of the particle, and use this name time to reference the time it took the particle to escape the grid. Okay. So we have to calculate the time it took for the particle to escape the grid. Basically, the number of moves. Each time, every second, there's a probability for each time step that can move up, down, so forth. So each one of these represents if it moves up, it took 1 second, move down 1 square. So if we look at, we basically got something like this. So open up Paint. So if we look at it, we basically have something like we have we have a square. Right, let's see if I can add a little shape. So we have a square, right? Then at the center of the square, so we're at the center, I'm going to assume this to be the center here. Okay, at the center, the center of the square. Okay, I'm just going to assume that to be the center. I'm not exactly perfect, but at the center, we have a little particle that starts here. Little particle that starts here. Let's call this y. This is our y-axis, and then this is our x-axis, right? So this is I'll just call this x. So this is our x-axis, and you'll see here that we have a probability. So every time step, there's a probability for this particle to move up one. So it means it can move there, or it can move there, it can move down one, with another probability for it to move that way. Let's assume left, it can move that way. So let's just assume that it moved there, right? Then it has another probability to move there, 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 or even stay and just not move, right? So every time this happens, it represents one new time step. So we have our question here. Wait, so let's see, here's our question. Let's just put it there. So, okay. So if we look here, so yeah, this is Instructor Basics. We're doing tutorial. Now this is tutorial 4. Well, this is past tutorial assignment, T4. And then this is question 3, right? So they say consider an assimilation of the diffusion of a particle in the medium, and the particle starts in the cell. So as remember, it's starting in the center of the cell, guys. Starting in the center, and then it can move one. And the goal is we need to it can move the up, left, right, anywhere at each time step, but eventually it's going to come a point where it's going to be outside, like say here or there, right? It's going to be outside. So when it's outside, then the program needs to stop. So remember that this is an 11 by 11 grid. So this is over here. If we take our, so this over here, this over here, this is 11. Wait, sorry. Basically, if we look here, this is 11 meters, right? And then this over here is 11 meters. So we have our little code here. So then this is obviously also 11, not necessarily 11 meters, just 11 by 11, but 11 units. So just erase this. Okay, so that's 11 blocks. So it's basically 11 by 11, right? 11 units, 11 blocks, whatever you want to call it. But the point is there's 11 equal blocks, right? So it can move this way, it can move this way, and eventually it's going to fall outside here. So do you guys agree with me that this is 5 point, this is, so this means this is 5.5. It's 5.5 over here is 5.5, right, for x. And obviously this will be minus 5.5 and minus 5.5 because it's 11. Yeah, so remember overall it's 11, but it's 5.5, 5.5, and so forth, right? So let's get back to our question over here. So they didn't say anything about creating a function or anything, so we're just going to make a code. So the first things first is we see that there's an equal probability to move. So if we see probability, then we know we must import random as R. We import the random module, and because it's equal probability, it means we're going to say our probability, our prob, is equals to r.randin. So we can just choose chance, like based on the chance, we can choose different units. So if we look here, we have one probability for this to happen. Oh wait, there's another probability for this to happen. There's another probability for this to happen. So there's one probability for it to move up by 1 square, move another probability to move down by 1 square, another one to move 1 square to the left, another one square to the right, or stay in the same cell. So that means there's 5 different probability states. So we're just going to say 1 to 5. Okay. So yeah. So So yeah, so literally what 1, 2, 5. But remember now is that this the uh this little cell or this little particle in this membrane or in the grid, eventually it's going to move up, it's going to move down, and so forth. Eventually it's going to move out. So every single second that passes, it means that so 1 second it moves up, then another second it moves this way, another second it moves down, another second it stays in the same place, another second, and so forth. Eventually it's going to be outside. So we don't know when it's going to be outside, but we know we have to simulate this time response, right? This particle moving in this medium. So we don't know when it's going to be, when it's going to happen, but we know it's going to happen over and over, which means we're going to have to use a while loop, right? While, so every second is a different probability, so we're going to say while, but we don't know what the condition should be in this case. But if we want to think about it in advance, we can, because basically this is our x-axis we see here. This is our, oh wait, let's just move this. This is our x-axis here, and this is our y-axis, right? So basically, the if it falls anywhere between here, if the absolute value of the y position, so basically if we say while absolute x, well absolute x is, so when should it run? It should run whilst it's below 5.5. But remember, it's one of the conditions needs to be met. Either the absolute value of x. So remember, if it's below 5.5, then it should run. So only one condition needs to be met, right? Only one of them. Either the absolute is above 5.5, so we're going to use an and. Absolute of y is below 5.5. So this is when it should run, right? Now obviously our probability, every single second that passes in this particle, or every single second that passes of the particle moving, that's a different probability, right? So it means it has to go inside the while loop. And all we do is, it's quite easy. From here, we just say if prob is equals to 1, right? Then if we come back to our condition, it's move up by 1 square. So then y, so we just need to start with our initial condition. So we'll say y is equal to 0 and x is initially equal to 0, right? Because that's the initial. They say it starts at the center, and the center of a Cartesian plane is 0, 0 for x and y, right? So if prob is equal to 1, then y plus or equals to 1, right? Then we say aleph prob is, oh wait, you see I forgot, I made a mistake. That's supposed to be 2 equals 2. If prob is equals to 2, aleph prob is equal to 2, then move down by 1 square. So y minus equals to 1, right? Okay, then we're going to say aleph prob equals to 3, then x, because we say it moves 1 square to the left. Now to the left is obviously this way, so minus equals to 1. So to the left means it's literally just going to move this way. So it's minus 1, right? And then we take this, we copy it. Okay, so here, and then we just, okay, so then else, the thing is, in this specific case, there's only the last one, because we don't really need to define prob 4, we can just say else x plus or equals to 1, because there's nothing really else that can happen, right? But if you see here, the probability is 5, then none of these will run. We'll just skip it, right? So we also need to define our time step. So we'll say t, which is equal to 0, and every loop represents one time step, right? So then all we do is we say t plus or equals to 1. Then we have that, and then at the end, let's just print the t. But actually, before you run any while loop question, don't put any print or anything. Just run it as it is. Just run it. Just run it and then see if there's no star there. You see there's no star, just put a number, or it's blank if it's like this, or this. As long as there's no star, it means the while loop ran. So don't put any print or anything. Put a print, it causes problems. So just say if there's an infinite loop. So rather, as if you see that it runs, then you can put a print. So there's no star as we see. Then we're going to say print t, because that's what we want at the end. So the while loop represents the simulation of the um, the throws, not the throws of the movement of the particle. And then we have our x value, and then we can print our y value. Okay, so we run it, and then we see we get 6 minus 2. So run it again, we get 14.6. But if you want it in more detail, like standard Cartesian coordinates for the x position, we can just say, brackets, then you can put that thing there, put another bracket there, and then we can say, so there's a bracket, and then we'll say x, then we put another thing here, we separate it, we put that, and then we put another one, and then we have that. And now we put y, and then put another one. So basically each separation, each comma represents, so you first print that, then you print that, then you print that, then you print that, and then you print that. So it's all in sequence, and we run it now, shift enter, and we see we get 6 and 3. Okay, so that's cool. That's the x, that's the y. We see the x lies outside. So we run it again. We can run it again, and we'll see we get 44. So it took 44 seconds, basically, or 44 time steps for this 2 and 6 to come through, right? So for the y, so now it lies y. But now if you want to know what the actual coordinate is, right? Because everything actually should work. Let's run it again. Let's run it again. -4, -2. So we see that it now lies 6. So it's basically 6 minus 2, which is over here. So it means that it's about there somewhere, right? At the time that it ended. Just note another way that you can do this, and this is where for loops are nice. So we can just copy this. Another way, if you want to define the condition, another way that you can do this is, so this is way 2 for the, so this is of the while loop condition. Another way that we can do this is, instead of just putting that, if you don't know what that should be initially, you can just say while d, and then set d equal to true, or even just say condition con is equal to true. So you know that's the condition, and then you put con, and then at the end of all of this, right at the end, you say if absolute x is below, is above. So what's nice about the if statement condition is literally what it is. If the absolute is above 5.5, so either one of them, right? Or absolute, just the opposite of the while loop condition, right? So either, yes, or absolute is 5, absolute y is above 5.5, right? Then our cont is equals to false, and then it will stop. So that's what's nice about if statements. You can add a condition like that, and then we'll see, let's see if it runs, if it works. Okay, that's nice. So yeah, it gave us 2 because it's obviously 2 different results. Okay, cool guys. This is the very basic net structure question, but it's interesting because it's combining probability, while loops, and then these while loops and if statements. So it's a basic net structure question, and then we're counting time steps. But in this case, it's just important that you understand how to convert math into what's been asked. As you see the probability and so forth. And remember, just in your case, if you were doing this with the random int, if using numpy, you'll say random dot rand int, and then you'll say from 1 to 6. That's what you would say, right? That's because it's always +1 for np.random. But if you just import random straight, as we have, you just use it like that. Okay, guys, so that's that. We run it, we see we get 0, 6, -1. Okay, everything's good there. Our code works, everything is good. So let's see here. Okay, so we just did this question. Now another interesting question with nested structures is prime numbers function, right? So we can have there's a little example. So let's leave this quickly. There's another little example that I have. Okay, we have another little example with prime numbers. If we look here, so okay, that's that. Another one with prime numbers. So we say, okay, now create a function, multiple tester, takes an integer, divisible, no. So what we're looking for is we want to create a function where, let's come here, where we're going to create a prime function. Okay, multiple tester. Okay, so let's just leave this and then let's just come to videos, Mr. True. I just want to open up the other one quickly. So classes, let's see this one. Okay, so there's a little example I did here, which is quite a nice one with, let's see, yeah, this one. So this is the example I want to look at quickly. So if we come here, so this is where we are. So we were at the video here. So this is another nested structure one. So this is another nested structure example. And they say create a function called prime numbers that takes a positive integer and returns an array of all the prime numbers below below the positive integer. Let's say n, integer n, and returns an array of all the positive numbers. So it obviously, so in this case, so this is how they give it to you in the semester test. So if you want to create a cell below, you can just push shift enter. So this is how they give it to you. They'll say prime numbers, and then in here they're gonna put so df prime numbers, and they're gonna put n, and then what you're going to return, obviously in this case, is, so we don't know what, so this is what they'll give it to you, and then they'll say print, so they'll say n says equal to n is equals to 20, or say 30, and then they'll put that in there. So this is generally how they give it in the semester test. Now you need to find all the prime numbers below 30. You write a code that finds all the prime numbers below 30. So what we'll do is in our little cell here, in our empty notebook, we'll say prime numbers. This is for our prime numbers question example. Now we want to find all the prime numbers below, so yeah, so we're going to find all the prime numbers. So prime numbers example, and remember what we're going to do is we're going to divide our code into 3. So we're going to say, so we can import modules first. So we're going to import, usually numpy is np, it's just like a standard thing, because arrays, or if we need anything, at least we know, okay. Then the next thing is our input, which is n is 30, right? And then now this is obviously where our code is going to go. So what we can do is, before we start worrying about our input and all of this, finding the prime numbers below 30, what we can do is let's just prove that a number is prime. So let's just prove that, say, n equal to 7 is prime. Let's prove it. Okay. So what is a prime number? Prime number is any number that has no divisor other than 1 in itself. So what we can do is, if we want to find a prime number, to test a prime number in Python, you can just find all the numbers between, say, from 2 to 6 in this case, from, if it's 7, from 2 to 6, 2, 3, 4, 5, 6, and then check if it's divisible, if all the way up until other than 1, and it's that number itself, and then then we just count the number of factors. If it's divisible, then we have, then if there's any factors, if there's any numbers that's divisible, i.e. remainder is 0, then it's not a prime number, right? So what we'll do is we'll say for, we can even call this number, right? Call this number, and then we'll say for n in range. And what we're going to do is we're going to start at 2, and we're going to go until num, right? In steps of 1. But that's mostly default, so you don't have to worry about that. And then, so It's a default 1. Remember, there's a default 1 there, so we don't have to really worry about that. But if you want to, you can put it there, but doesn't really matter. This is a default 1. So we say for n in range 2 to num. Right, now what we're going to do is we're generating each number. So we're going to have something like this. We're going to have 7. So we're going to take the prime number. So we're going to have 7 percentage 2. Then what's that? Uh, then we're going to say 7 percentage 3. Then we're going to say 7 percentage 4 and so forth. And we're going to do this for all the numbers up until 6, right? The reason why is because we want to just count the number of factors. So the goal now is let's just find number. So this is we're going to have like one smaller goal, find number of factors. So what we do is it's straightforward. We just say if our number is divisible by n, and that's equal to 0. So if you take number and you divide it by 0, divide it by n, 2, 3, 4, 5, 6 equal to 0, then count the number of factors. So say f and t for factors, we'll set that equal to 0, and then we'll say f and t plus or equals to 1. Remember, that's f and t equals to f and t plus 1. So we have that. And then then we'll say print f and t, that's a very simple code. Run it and we'll see we get 0 because 7 has 0 factors, but we know 8 has 2 and it has 4. So if we say 8, it should give us 2, right? So we know that a prime number is anything now with 0 factors. So then we say if f and t is equal to 0, then print prime. Then print prime. If it's else print not prime. So we have prime and then we have not prime, right? So 8 is obviously, if we look here, wait, zoom in, we'll see that 8 is not prime. So if I put 9 here, and I run it, we know that's not prime, but if we put 7 here, we'll know that it's prime. So we just proved one number. We kept it simple. And it's able to find all the prime numbers, but for now, just keep it simple in the beginning. So the idea is you have small goals and you convert each small thing into a code. So in this case, what does this code do is it tells you whether a number is prime or not. So we can create a little function for that. Yeah, so we can get rid of that, and then we can say def, we'll call it prime tester, and then we're going to put our num in there. Our number, it has to correlate. We're going to put our number that tells you whether that number is prime or not. I'm going to put number in there. So you're going to create your own little function. Then what we'll do is we'll move that up there. And then we'll say, okay, so we have prime tester. Okay, we have prime tester. Now remember that at the end of the day, the function has to return something. So if something is prime, it means it's true. So to Python, something is either true or false. So we're going to return true. And then we're going to return false. So it means it's not prime, right? Either A, it's true or it's not true. Okay. So then we're going to say print, and then we're going to put prime tester. So just to see that everything works. So we know that it's just, trust me guys, it's always easier if you make something return true or false. So if it does one thing and it's tell you whether something is prime or not, or whether it's a even number or odd number or something like that. It's always nice to have a little function that tells you that, and then returning true or false. But now let's put 7 in there, and we'll see that it should say true. It should say true. It says true. If we put say 9, it should say false. Why? Because of the way we've defined it. Okay, so that works. We're happy. Now remember the goal was to find all the prime numbers below 30. So then what we do is we say for for n in, or we can even say for num in range. And now we all know that 1 is not a prime, so we're going to say from 2 to n. Now it's all the numbers below, not including that number, so below. So we're not going to say +1 or anything, just until n, because remember it's always going to be -1. So then if a number is prime, so then it's very straightforward. So we'll create an empty list. We'll call it, say, primes empty list, and then all we do is we say if, and we can actually use this as a function. I mean as a condition, because remember it's returning true or false. This is nice about it. We say if, wait, we say if this, and we say if num. Okay, so I say for num in range 2 to n, and I say if prime tester num. Okay, so if prime tester num. Now obviously we have num in there, and then num's going to go there, and that's going to come in here. But remember, you don't always have to call that num. You can make that n, and you can make that small n in here, and that small n, it's just the number that's going to put there. It's still correct. I know that small n there, but it's not really going to make a difference in this case, because remember that this num is an object, and that's an object, and this is with respect to that. So this is just an object name we put in there. That's basically, when that's 3, it basically just puts 3 there, and it sets num equal to 3, not to n. Okay, so, but we're going to put n there. Or num, I think it's just, let's just keep it simpler for you guys. So we're going to say num, and then we're going to say so if it is prime, it's true, then we just say primes dot append, and then we say that number is prime. So that number is prime. Then at the end we can just say print primes. That's what we want. Below 30, we run it, we get all the prime numbers below 30, and that code is nice. And we can make it even 200, and we can find all the primes below 200. And we see there's all the prime numbers below 200. That is pretty cool, right? So this is our code. Everything is working. Just make sure there's no duplicates. Make sure everything is working fine. Everything's good. So this is our code, and you just copy it, move it, then copy it. And then all we do is we come and we paste it in our function, including that function. You also paste the function we created in there. The reason being is when the computer marks it, they don't, like, remember, imagine this is your method test, so you can actually get rid of this. We don't really have to worry about this, but I'm just, yeah, you don't have to really, it's not gonna, the computer won't read it, but it's fine, everything's there. So that's it there, and remember just to so if you run it, like, say you just left it like that and you run it, you're going to get none because it's not returning anything. Like, it'll print it, but just rather say, get rid of that and put a return. Okay, in the place of that, the print. So remember the answer we wanted, that's what you're returning. And then, because returns an array, but remember they said they want an array of all the prime numbers, an array. And remember this right now is a list that is returning. This is a list. So then all you do is you say np.array. And that's it. Array converts a list, which is here, into an array. So we run it. Now you see it will change. 2, 3, 6, so forth. And just remember to keep the function inside there, because when the computer's marking, it doesn't know what prime tester is, but it knows it's looking for this. This is what it's looking for. DF prime numbers. It finds it, like, okay, cool, then it'll just run whatever in here. Okay, so that's our prime tester. It found all the primes. And that is everything. Cool stuff. This is prime numbers. This is a prime number example. Now, yeah, that's it over there. Everything works. In our semester test, we run it, we get our answer. Great stuff, guys.